Hey guys, so today we are going to see that what is parallel projection. So in parallel projection, the coordinate positions are transformed to the view plane along parallel lines. That is, the coordinate positions of the object are then transformed or they are projected to the view plane along parallel lines. We will see later that what this means. Now the second point is that a parallel projection or a projection is said to be parallel if the center of projection, also known as the COP, is at infinite distance from the projected plane. Now let us suppose that we have a plane over here, that is the projected plane, or we can also say the image plane. That is, this is the projected plane or the image plane. Now suppose we have an object over here, that is, suppose we have a stick which has coordinates or points as A and B. That is, say this is the object. Now we will draw parallel lines from the coordinates, that is from the coordinate positions that we saw over here. That is, from the coordinate positions we will be drawing parallel lines, or we will be extending or projecting parallel lines onto the surface of the projected plane or the image plane. That is, over here we will get the image. That is, this is point A and this is point B. And the center of projection will be at infinity. That is, when we extend these lines, as we know that when parallel lines are extended, they will never intersect even at infinity. So a person over here, say this is the center of projection, will never see these lines intersect. So what we will say that the center of projection is at infinity. That is, this is the center of projection, it will be at infinity. So this is what is meant by the first point and the second point. Now we will be seeing this point, that is the third point. The projection lines are parallel to each other and they extend from the object and intersect the view plane. Now what they mean to say here is that from the object the parallel lines are projected and they intersect the projected plane. That is, this is the projected plane which is being intersected by the projected parallel lines which forms the object over here. That is this part. Now these parallel projected lines when extended will mean that the center of projection is at infinity. So whenever the center of projection is at infinity, it is always sure, or you should always be certain that we are talking about parallel projection. This is the key point of parallel projection. Now we will see that how we will derive a formula for parallel projection. That is, let me write derivation. Now guys, this is an important derivation, so please listen carefully. So now let us suppose the direction of projection is given by xp, yp and zp. That is the direction of projection of the line or of the point is given by xp, yp and zp coordinates. These are the direction of projection. Now the object and the image is to be projected onto the xy plane. That is the object. It is to be projected on the xy plane. That is on a 2D plane. That is, this is a 3D object and we are projecting it on a 2D plane. As we learned earlier that projecting an n-dimensional body into n-1 dimension is known as projection. So that is what we are doing over here. Now let us see that we have another point on the object. Say the point on the object is given by x1, y1 and z1. So first we have 3 points, that is direction of projection. The object is being projected on the xy plane, and third point is that the point on the object is given by x1, y1 and z1. So now let us begin by writing the equations of a line passing through the point x, y and z. Suppose this is our object and parallel lines are passing through it. Then on the line of projection, that is the line passing through the point x, y and z. So suppose this is the line of projection and a point on it is given by x, y and z. So we will be finding out that, and it is in the direction of projection. That is, this point is in the direction of projection. This is the object and here will be the image plane or the projection plane. So now let us write the parametric form of the equation of the lines in all 3 coordinates. Parametric form, or we can also write parametric equations that we will be getting. That is, we will get x is equal to x1 plus xpu and y is equal to y1 plus ypu, and z is equal to z1 plus zpu. So guys, this is the parametric form or the equations that we will be writing for this point, that is x, y and z, and x1 over here is the point on the object, that is this over here, and xp, yp and zp is the direction of projection or the point of the projection lines. Now this line will intersect the xy plane, that is these lines will intersect the xy plane. Now what we mean by that, is that suppose this is the xy plane. So for sure on the xy plane, the z coordinate of any point, suppose this is a point A. So the z coordinate of point A will always be 0. That is, we will not have any z coordinate. So what we can infer from this is that this point or this equation, this equation will be equated to 0, or the z point, that is this point, will be 0. So from there we can write that 0 is equal to z1 plus zpu. So from here we will get the value of u, which will come out to be equal to minus z1 upon zp. So this is what you will get on putting z equal to 0, as we are projecting on the xy plane, that is on the 2D plane, and you know in a 2D plane we have only two coordinates, that is x and y, and z is equal to 0. So from here we will see that we get the value of u as this. So now we will be putting the value of u in the equations 1 and equation 2, that is we will be putting a in 1 and 2. On doing so, you will get the value of x as x1 minus xp, z1 by zp, and value of y as y1 minus yp, z1 by zp. So these two are the final equations that we will be using in order to solve the numericals given for parallel projection. That is, the derivation starts from here. So first we wrote these 3 points, that is the direction of projection. Then we wrote that we are projecting the object on a 2D plane. Then we wrote that the point on the object is given by x1, y1 and z1. And then we saw that where is x, y and z, and over here will be point x1, y1 and z1 on the object, and this is the image plane. Then we wrote the equations of the lines in parametric form, that is over here. And then we inferred that if we are projecting on the xy plane, that is on the 2D plane, then the z axis will always be 0. Now on doing so, that is we are putting z equal to 0, and from there we will get the value of u as minus z1 by zp. So we simply use this value and put it in this equation, that is 1 and 2. Now doing so, we will get the value of parametric equations as this. So we can use these equations and write them in the form of a matrix. Now how we will do that? That is, we will get x2, y2 and z2. Suppose these are the coordinates that we want to find. Then we will write x1, y1 and z1 over here, and then we will write 1 0 0 0 1 0 minus xp by zp minus yp by zp, and this will come out to be 1. Or you can simply write x, y and z is equal to x1, y1, z1 into the matrix 1 0 0 0 1 0 minus xp by zp minus yp by zp into 1. Now how I got this? Suppose if you multiply these two matrices, that is these two matrices, you will get the value of x as the similar one as we got from the above equation, that is x is equal to x1 minus xp, z1 by zp, and you will get the value of y as y1 minus yp into z1 minus zp. But the value of z you will get as 0. That is, the value that you will get for z will be 0, or we can say z1. Okay, so now we will be writing it in another form. Suppose if we want to write it in further simplified form or in a homogeneous coordinate form, that is in a 4 cross 4 matrix, then what we will do it as we will write x2, y2, z2, and then we will just add 1 over here. That is in order to write in a 4 cross 4 form, that is in the homogeneous coordinate form. And this point will be written as x1, y1, z1 and 1, and over here the matrix will come out to be 1 0 0 0, that is a 4 cross 4 matrix, 0 1 0 0 0 minus xp that is minus xp will come over here, minus xp by zp minus yp by zp, 1 0, and over here we will have 0 0 0 1. Now on doing so, you will get the value as this. That is, this is your final form or the final homogeneous matrix that we will get by this matrix. So this is a homogeneous coordinate form. Now we are only interested in x and y, that is we are not interested in z because we are projecting on a 2D plane. So only take out the values for x and y. That is, you can also use a homogeneous matrix, or you can straight away use this 3 by 3 matrix. That is, this is a 3 cross 3 matrix. But writing a derivation till here is good because over here you will get full marks because the homogeneous form is important. Now guys, if you were able to understand this, that is what is parallel projection and how do we find out the formula for this, just write wow in the comment section, and it would be great to know that you were able to understand it. And guys, please don't forget to subscribe our channel, as it would help us to create more such videos in order to help you understand quickly and fast. Now guys, this is it for this video. See you in the next one.